There are 50 trillion extracellular vesicles flowing through your veins right now. That's 50 million packets of information that all your cells make to communicate their contents and instructions to other cells. Extracellular vesicles, or EVs, are important in lots of normal processes like healing and immunity, but in the presence of disease, different EVs will arise. Tumor cells, for example, can create EVs that trick healthy tissue into advancing the spread of cancer. Now, if you could somehow monitor all of the EVs in your body, you would be able to diagnose any disease, HIV, Alzheimer's, cancer, all from a simple blood sample. So why aren't we using EV-based diagnosis already? To understand that, let's imagine your body is a business. All your cells are its employees, and EVs are messages being sent between them. The disease is a corporate spy trying to take down the company. To catch this malicious actor, we're going to need to intercept their secret messages. Likewise, to understand what's making someone ill, we need to detect those disease EVs. The challenge then is that your body is a very complex business. So many employees in so many different roles, sending countless memos and mail, but who are they from? Where are they going? What's their purpose? To find just a few EVs in a sea of trillions, we'll need a tool that can tell us as much as possible about each individual EV so that we can distinguish the disease EVs and catch them when they appear. Now, what might this tool need to tell us? Well, the contents of an EV can tell us where it's from and what it's doing, while the size of an EV can tell us how it was made and how it'll interact with cells. We can label EVs with markers that are specific to their unique contents and use a relatively normal microscope to observe that. I can also measure special behaviors of light on these labeled EVs to acquire their sizes at the same time. My technique is fast, requires no specialized instrumentation, will measure EVs smaller and more accurately than other methods, and importantly, give us size and contents information about individual EVs. What all that means is that this technique is going to be accessible to more scientists who can take advantage of it to create a foundation of knowledge upon which we could build a universal EV diagnostic method. What I'm working towards is a future where you can go see your family physician, have a little blood drawn, and from that diagnose any condition. A future where that diagnosis doesn't take weeks and months, one where it takes just hours, giving you back that time to take action, preserve your health, maybe even save your life. Thank you.